Hello and welcome back. In this video I'm going to continue talking to you about dividing. I've already done a couple of videos where I've explained how dividing can be sharing or it can be grouping, and I really recommend you watch those if you're not sure what I'm talking about. Anyway, let's get straight down to business, and what I'm going to do here is help you actually solve division problems and questions. So if I have, for example, let's go for 15 divided by 5. Now we know that that can be sharing. I've got 15 and I'm sharing it between 5 people. But if you look at the video I've done on grouping, you can see that the way I often do to solve this is to look at the grouping way, in which I'm saying how many groups of 5 are there in 15. And I'm going to put this little arrow going back here because that's what I'm going to be dealing with again. I'm moving on from the last video, which was solving simple division problems, and what we did in that is we were counting. We were counting up in groups of 5 to find out how many 5's in 15, like this. So let's start off with 5, 10, and there we go, I get to 15. So how many groups of 5 were there? There were 3, and that's my answer. 15 divided by 5 is 3. Let's just do another couple of examples of that. So let's do 20 divided by 4. So I really want to get you confident about this idea that, as well as saying that I'm sharing 20 between 4 people, for example, if I had 20 and 20 sweets and I shared it amongst 4 people, they'd all get 5. I want you to be thinking and confident with the fact that I'm also saying how many groups of 4 are there in 20. And we'll put this arrow back here again. How many groups of 4 are there in 20? Let's count up in 4. 4, 8, 12, 16, 20. 1, 2, 3, 4, 5. And that gives me my answer. Now, what I'm going to do now is move on from this so that you can use your knowledge of times tables without actually needing to count up like I've just gone over again here and I explained in a previous video. And I'm going to do something called using the inverse operation. And this is quite complicated, this language, and you may not need to know it now. But what it means is, whilst I'm dividing, the inverse is like the opposite. And the opposite of dividing is multiplying. So going back to this question, I've been asking myself, I'm saying how many 4's are there in 20? And I counted up in 4. 4, 8, 12, 16, 20. I'm now going to write that mathematically. I'm going to say how many, and I don't know, how many lots of 4 equal 20. So what I've basically done is this statement I've done at the top, which is dividing, is also asking how many of a number go into a number. I know that 20 divided by 4 is saying how many 4's are there in 20, and I'm just writing it out. I'm saying how many groups of 4, because that's what multiplying means, how many groups of 4 make 20. And I know my 4 times table, so I know that the answer is 5. 5 times 4 is 20, so it was 5 lots of 4 make 20, which made my answer there. Let me show you a couple of other examples. So let's go for 21 divided by 7. So the first thing I'm going to ask myself is, I'm just going to make sure I know exactly what I'm doing, which is I'm asking how many groups of 7 there are in 21. So let's now write that out. How many, I don't know at the moment, how many 7's equal 21? If I know my 7 times tables, I know that it is 3. So therefore, that is my answer. And 21 split into 7 groups, each one of them would have 3, because 3 times 7 makes 21. And that's using the inverse operation. It's using my knowledge of times tables. Let's do another one. Let's go for 35 divided by 5. So it should be becoming almost second nature now to ask how many 5's are there in 35. Now, if I'm not confident with my times table, I can just count up in 5's and see how many I've got, like this. But what I'd like you to start thinking about doing is writing out the inverse, or thinking, well, how many 5s in 35? And I'm going to write it like this: how many times 5 equals 35? Well, I know my 5 times table quite well, and I know that there are 7 5s make 35. There we go. 7 5s are 35. So 35 divided by 5 must be 7. Let's do a couple more just so that you can see how this works. Let's go for 28 divided by 4. So I'm saying, how many 4s are there in 28? How many 4s in 28? If I was going to write that as a number sentence, it's saying how many? I don't know, so I'll put a question mark. How many lots of 4 equal 28? Well, I know my 4 times table, and I know that it's 7 lots of 4 make 28, so that must be my answer. Let's do another one. Let's go for 27 divided by 3. So how many 3s are there in 27? How many groups of 3? Remember we had the counters and we were just going in the groups going up. How many 3s in 27? Let's write that down. How many times 3 equals 27? Well, I know my 3 times table, and I know that I need 9. 9 3s are 27, so 27 divided by 3 equals 9. So by understanding that dividing is grouping, by saying how many groups of 7, how many 7s in 21, that's the first thing we need to get to grips with. And then I can either count up, or I can use my knowledge of times tables and what we call the inverse operation to say how many 7s in 21, how many 7s make 21, and it's 3. 3 7s are 21, so 21 divided by 7, or how many 7s in 21, must be 3. I really recommend going back and looking at my other videos where I explain about what sharing is and what grouping is, and how they're different, although they are both dividing. And also go and look at the video in which I'm counting up, and then you can move on and make use of your times tables. And once you get this and you've got a good knowledge of times tables, you can just work out your division problems just like that. As always, good luck. I hope this makes sense. Watch the videos again, and all the best with your work.